Hello, friends. Part two of our podcast on section 11.2 in the AP Stats book. We had just finished talking about the first three parts of the inference toolbox, the sentences or the math that should be included. And the last thing you know is the important part. This is where you make it all pay off, and that is by writing some conclusion, some interpretation of the result. So you're going to use the language stated in the question, and you are going to answer the question. Make sure you answer what they ask for. Answer the question in context with the math results that you get from your procedures. All right, so basically you're trying to make clear to someone that does not have as many statistical skills as you what the answer means. So I'm going to walk through one problem from the book, and then we're going to try and hone our skills in class tomorrow. And the problem we're going to do is on page 709 in your textbook. You should go get your textbook and open it up and get your calculator right now. The first thing that we're going to do is put the data in the calculator. So let's read the question and see what we're up against. Remember, we want to take this question apart, just like I showed you in class last time. All right, so we suspect that students will generally score higher the second time they take an SAT math exam than on their first attempt. Suppose we know that changes in score, the second minus the first, have population standard deviation sigma. So before I tell you, in your head, decide what this means. Pause if you need to. Okay, so what this tells me is if I have a sigma, first of all, it's got to be a mean problem. And that should be obvious because here I have a list of numbers. Second of all, because I know sigma, that means I can do Z procedures. Okay, so these things I know right off the bat. And sigma is 50. Okay, here are the results of 46 randomly chosen. So what they did, and going back to what we learned at the beginning of the year, this is a matched pairs experiment. And it's matched pairs because each student took the test 2 times and they just subtracted the second from the first. So this is a list of numbers that I got. So what I would expect is if the second one was higher and I subtracted the first, I should get a positive number. Right? So second's bigger and I take the first away, I should get a positive number. And you can see in this list that they're not all positive. But let's see what happens when I put this in the calculator. So get your calculator and punch the data in. Now the point of question A here is just to establish normality. They want a graphical display. And you can make anything you want. You can make a histogram, box and whisker. We're going to make both of those. But you could do a stem and leaf if you were doing it by hand. So let's see what this distribution looks like. So with the calculator on, I am going to go to second stat plot. I'm going to go to the first plot, turn it on. I am going to make the histogram first. I'm going to use the list in L1, and I'm going to have the frequency stay 1, so I'm all set to go. I'm also going to make a box and whisker so I can look at both. So if I go up to the plot 2 and hit enter, I'll go there. I'm going to turn that on, and I'm going to go down to the modified box plot, this one that's flashing right here, and hit enter. And I do that so I can see if there's any outliers, and I want my frequency to be 1. And if yours is a flashing alpha and has a list in it, then you got to hit the alpha button to get out of the alpha and hit 1. At this point, I can just hit zoom 9, and I get this not so nice looking picture. So I'm going to fix that with the window. So you can see the window that I set. You can pause and set your calculator like that, and then hit the graph button, and you get something a lot prettier. And you can see the image that I get. I got no outliers, and critical thing is that here is my 0. So in the context of this problem, all the numbers that are here are people that did better the second time they took the SAT, and everyone here has a negative number, so that means they went down. So you can see it's slightly more than half, okay, but it's close to half that went down the second time they took it. So we'll wrap this up in the last podcast.